Jai Hind, my dear student. I am Akriti Gupta and I am going to present this lecture which is on the topic internal combustion and engine. It is given in the subject of fundamentals of mechanical engineering and mechatronics. So this is our second lecture in this topic. In previous lecture I have discussed about the components, construction of IC engine and the main types of IC engine. In today's lecture I will discuss about the CI engine. So before starting about the CI engine, let's take a quick revision of SI engine. As in previous lecture, I have discussed about this SI engine, 2-stroke and 4-stroke engine. So in SI engine, basically it was a type on the basis of types of ignition. So this fundamental difference between SI and CI engine, that is how ignition is being ignited or combustion is initiated in SI engine or CI engine. In SI engine, a spark plug is used in igniting or burning of the fuel, but in case of compression ignition engine, it is compressed and temperature and pressure inside the cylinder is raised and self ignition of the fuel is done in CI engine. This is self ignition. This is the main difference between SI engine and CI engine. In CI engine, we use the fuel whose self ignition temperature is very low comparatively the fuel we are using in SI engines. So here in CI engine, a fuel is used who is having very low self ignition temperature and compression is done inside the cylinder, which raises the pressure and temperature of the cylinder, and at a certain point when pressure and temperature inside the cylinder is this much high that it can ignite the fuel, then we supply the fuel with the help of fuel injector and fuel pump. So in this way we can say a CI engine is an engine in which the fuel charge is ignited by the heat of compression, and the process of combustion in the CI engine is fundamentally different from that in a SI engine. So here it is ideal diesel cycle on which a CI engine works. This is thermodynamic cycle. As in previous lecture I have discussed the Otto cycle on which SI engine works. There is basic difference in one process in comparison with SI engine is heat injection process, or where combustion is done in which process, that is 2-3. In SI engine it was done under constant volume process, but in this case it is done under constant pressure process. So here are the 4 processes. Number 1 from 1 to 2, that is isentropic compression. Second process, that is 2 to 3, that is constant pressure combustion. Process 3 to 4, again it is isentropic expansion, and then it comes process 4-1 where heat is rejected, that is constant volume heat rejection process. In comparison with SI engine, all 3 processes are same in reference to Otto cycle, but in this case only one process is different, that is heat injection process. Now this is 4-stroke diesel engine. All the constructional details are same from the SI engine. There is certain difference between the working of SI engine and CI engine, in which fuel is supplied at the power stroke in CI engine, while in SI engine it was being supplied in first stroke, that is intake or suction stroke. So starting with intake, or we call it suction stroke. First stroke in 4-stroke diesel engine is suction stroke. as in construction, this is inlet valve or inlet manifold. This is inlet manifold where fuel is supplied. This is inlet valve, this is exhaust valve, and this is just the mirror image. So this is intake, this is exhaust. Don't get confused. This is just a mirror image that we understood in the last SI engine series. So this is intake, this is exhaust, no problem. This is inlet valve, this is exhaust valve. In SI engine, a spark plug is mounted over the cylinder head, but in case of CI engine, no spark plug is provided. So first, as inlet valve opens and exhaust valve remains closed in this stroke. So what happens here? Fuel, as in case we are studying the case of CI engine, so no fuel is supplied in this case, only air is supplied. What is the difference between SI and CI engine? You can also learn the comparison between SI and CI engine from the working of these two. So only air is supplied in CI engine in first stroke, and inlet valve remains open and piston moves from TDC to BDC. TDC, that is top dead center, and BDC is bottom dead center. So piston moves from TDC to BDC, and this is the first stroke of the piston in CI engine. So as the pressure falls below the atmospheric pressure, so intake is done in this way. Now this is second stroke of CI engine, that is compression stroke. So now piston moves from BDC to TDC. So both valves remains closed in this stroke, and the air which was supplied in previous stroke is compressed in the second stroke, that is compression stroke. As compression is done and pressure and temperature raises very high in this stroke at the end of compression. Now as the end of compression reaches, a fuel injector, now it comes to third stroke, that is power stroke, or we generally called it expansion or working stroke. So now a fuel injector, this is fuel injector, is provided in CI engine. As remember, spark plug is provided only in case of SI engine, but in case of when we talk about CI engine, then fuel injector is provided. Fuel injector is used to supply the fuel. Now as pressure and temperature is already very high at the end of compression, now this is the time when fuel injector is used to supply the fuel in nanoparticles, and as the fuel is supplied, ignition is done or burning starts, and the high impulse is released on the piston, which forces the piston from TDC to BDC. And this reciprocating motion of the piston is transferred to crank and converted into rotary motion of the crank. So this is our power stroke, because high impulse and thrust produced by this burning of fuel and air is supplied to the piston. Now this is the last stroke, that is exhaust stroke. So as the name suggests, in this piston moves from BDC to TDC, and the burnt gases are forces out to the atmosphere, and the engine is ready to receive the fresh charge from intake. In this, exhaust valve opens and inlet valve remains closed, and piston moves from BDC to TDC. So in this way all the 4 strokes are done, but remember, power is supplied only in one stroke, that is your power stroke or expansion or working stroke. Main difference between SI and CI engine: in CI engine fuel injector is used, while in SI engine a spark plug is provided. In SI engine, air plus fuel is supplied, but in case of CI engine, only air is supplied in intake stroke. So remember, these are the basic difference between SI and CI engine. Now let's talk about two-stroke engines. As I discussed in our first lecture, what are the two-stroke engines and four-stroke engines? So in two-stroke, piston takes only two strokes. Stroke means movement of the piston from TDC to BDC. So piston takes only two stroke, then engine is two stroke, and if piston is taking four stroke, four movement of the piston from TDC to BDC and vice versa, then we call it four stroke engines. As I have already discussed two types of four stroke engine, that is, one is SI, CI. Two four stroke SI engine I have discussed in last lecture, and in this lecture I have discussed four stroke CI engine. So I have completed these two topics. Now come to two stroke engine. Now again we have to study two stroke SI engine and two stroke CI engine. So before going and understanding the working of two stroke engines, let's understand and discuss the differences between two-stroke and four-stroke engine. So first difference you can see in the construction of the engine. You can see here there is certain difference between the components of two-stroke and four-stroke. As you can see, this is four-stroke engine. Their construction is certainly different when we compare it with two-stroke engines. So now what are the constructional difference in two-stroke and four-stroke? First is there are no valves. When we talk about two-stroke engines, then there are no valves. No valves are used in this engine. Then what are used? Here ports are used. Ports are generally nothing but the passages provided on the cylinder block. So as you know, inlet valve and outlet valves, it means there are two types of valves which were being used in four-stroke engines, but in case of two-stroke engine, as ports are used, there are three types of ports, in which number one is inlet port, second is outlet port, and third is transfer port. So valves are replaced by the ports, and ports are in three numbers, that is inlet port, outlet port and transfer port. And there is one more difference between two-stroke and four-stroke, that is design of piston. Design of piston. In designing basically piston in two-stroke engine, there is crown. You can see this is crown which is provided over the piston. What is the purpose providing of this crown? I will discuss later. So now these are the two constructional difference between two-stroke and four-stroke engine. So now let's understand the working of two-stroke engines. So as one thing, remember Otto cycle and diesel cycle. When you talk about SI engine, then remember, you should remember Otto cycle, and when you talk about CI engines, then remember diesel cycle. You should know all the four processes of Otto cycle as well as diesel cycle. So it will be very easy to understand the working of two-stroke engine and four-stroke engine. So here were the four processes in diesel cycle as well as in Otto cycle. So now in case of four-stroke engine, what happens? Four strokes are there. Let me write it again. One is suction stroke, compression stroke, expansion stroke, and last one is exhaust stroke. So these are the four strokes in case of four-stroke engine. Generally what happens when you talk about 4-stroke engine, and as you know SI engine, if I am talking about the working of the SI engine, that you will remember Otto cycle. Otherwise if I am talking about the CI engines, then you will remember the cycle, that is diesel cycle. You know there are 4 processes in each cycle. So if there are 4-stroke, 4 processes, so it is very easy to understand. If suction processes, suction is, I am talking about the suction process, then you can see the process 1, 2, that was isentropic compression. Then if I am talking about the compression, then it was this, as well as in case compression, expansion, and this is if I am talking about supplying of heat, ignition, and then your heat rejection. So one process is 1 stroke. It is very easy to take the working of piston and the movement of the piston. But when it comes to 2-stroke engine, that is quite becomes complex to understand the working, because number of processes are still same. Because if CI engine, if there is CI engine, then cycle will be diesel cycle, and if there is SI engine, cycle will be your Otto cycle. So there is no change in the thermodynamic cycle of the engine. There is one change, that is the movement of the piston. So we have to process all the 4 processes given in the cycle, but we at the same time we need to remember that we have only 2 strokes. It means we have to process all the 4 process, but in 2 stroke of the piston. So it becomes a little complicated. No problem. So let's understand how the working of 2-stroke engine is done in this way. So remember, if there are 2 strokes, so 1 stroke I will call it down stroke, or you say first start with upstroke. Upward stroke of the piston, just remember this is first stroke, and if I talk about second stroke, then it will be downward stroke of the piston. 2-stroke, I am talking about 2-stroke, then 2 strokes are there, upward stroke of the piston and downward stroke of the piston. Now remember the processes are 4. It means each stroke is taking 2 processes. It means if in upward stroke of the piston, suction and compression is done simultaneously, and in the downward stroke of the piston, now remaining 2 processes will be expansion and exhaust stroke. All right. So these are the 2-stroke, and these are the all 4 processes. So in this way, what happens when I am talking about upward stroke of the piston? It means piston is moving upward, that is from BDC to TDC. These are the ports. Inlet port is here. It is provided in the crankcase. This is exhaust port. This is your transfer port. The opening and closing of the ports are done by the movement of the piston. So now what happens when piston moves from BDC to TDC? So as the movement of the piston is governed, is the opening and closing of the ports are governed by the movement of the piston. So when piston moves from BDC to TDC, the inlet port is uncovered. You can see the inlet port is uncovered. So what happens here? Then from inlet port, your initial yani fresh charge will be supplied, and it is supplied in the crankcase. In 4-stroke engine, it is supplied in the combustion chamber here. You remember, here were the inlet valve, and the fresh charge is supplied in combustion chamber. But in case of 2-stroke engine, it is supplied in crankcase. This is crankcase. So from inlet port, fresh charge is supplied in crankcase. Now as piston moves upward, the fresh charge which is already in combustion chamber is compressed. You can see piston is moving upward. So this here the charge will be compressed. So suction and compression is done simultaneously by only a single stroke of the piston, that is upward stroke. So now let's talk about the downward stroke of the piston. So what happens here? Just look, as in downward stroke, when it will go from TDC to BDC, So as first it will uncover exhaust port, because the designing of cylinder block is done in such a way that the opening will be governed by movement. So exhaust port opens here and the burnt gases, as at the end of compression, when it was compressed, when the fresh charge was compressed, then at the end of compression, if I am talking about the SI engine, then there will be a spark plug, and if I will talk about CI engine, then remember there will be fuel injector. So whatever the way, the fuel will be ignited here and it will, the heat energy will be released by the burnt gases. So it will move the piston downward, and in this way the exhaust port will be uncovered. From exhaust port, all the burnt gases will be delivered outside to the atmosphere. Now again, as piston moves downward, transfer port also opens, and the fresh charge which was supplied in first stroke of the piston, now it is compressed also in crankcase as piston will move downward. So this compression is also called crankcase compression, and this is partial compression which is done in the crankcase, so it is called crankcase compression. Now this partially compressed fresh charge is transferred to the combustion chamber through transfer port by the movement of the piston when it moves downward. So the fresh charge is supplied by transfer port. Now as there will be certain time or possibility that as the exhaust port is also open, transfer port is also open, so there will be possibility that some of the amount of fresh charge will escape from the exhaust port. To prevent this, there is a crown I talked about in designing of the piston. So there is crown provided over the piston which actually deflects the fresh charge to upward side of the combustion chamber. So this is the purpose of the designing a crown over the piston. It deflects the fresh charge to the combustion chamber. So possibility becomes less to escape out the fresh charge to the atmosphere. So this is the reason behind designing of piston. So in this way again our downward stroke is completed, in which expansion and your exhaust is done. So all the four processes are done in this way in two stroke of the piston, only in two stroke of the piston. So these are the basic difference in construction and working of two stroke and four stroke engine. Only remember the working of SI engine and CI engine almost remain same. There is basic difference only in providing in suction stroke, that is in CI engine only air will be supplied and the compression is done and then ignition is done with the help of fuel injector. But in case of SI engine, air plus fuel mixture is supplied and the ignition is done by using of spark plug. Now there is a term that comes in two stroke engine, that is scavenging. So basically scavenging, it is the process of forcing out the burnt gases from the cylinder for admitting the fresh charge into the cylinder. This action generally takes place in two stroke engine. So what happens when, as you have understood the design, you have understood the working of two stroke engine, so you should understand there will be certain time period where exhaust port and transfer port remains open. So scavenging is the process of forcing out the burnt gases with the help of fresh charge. So actually what is happening, fresh charge is basically forcing out the burnt gases to the atmosphere. So this simultaneously two things are done here simultaneously. One is forcing out of the burnt gases and admitting the fresh charge into the combustion chamber. So this simultaneously two things are done in this way, which is known as scavenging. So there are some points to remember in scavenging, that the charge as enters the engine cylinder from the crankcase at a pressure higher than the exhaust gases. As you know, when we talk about the suction process, then it is done at the pressure which is below the atmospheric pressure. So when I will talk about the fresh charge enters the engine cylinder from the crankcase, then it will be done at the pressure which is higher than the atmosphere. And then this fresh charge forces the exhaust gases to the atmosphere through the exhaust port. During the period, both the transfer and exhaust ports are kept open for a short period. Hence, there is possibility of the fresh charge escaping out with the burnt gases. Because since fresh charge it also helps the burnt gases to escape out, so there is possibility then certain amount of fresh charge also escapes out to the atmosphere. This is overcome by designing the piston to have a deflected shape. This shape of piston deflects the fresh charge upward and in the engine cylinder, that is combustion chamber. It also helps out in forcing out the exhaust gases to atmosphere. So by designing a crown over the piston, basically it reduces the possibility of escaping out of the fresh charge. This process is known as scavenging. Now there are certain comparison between SI engine and CI engine. So there are the criteria on which we will compare the SI engine and CI engine. So first criteria is combustion process. So you know ignition takes place by a spark generated by a spark plug in case of SI engine, while in case of CI engine it is done by the compression of air in the chamber. Compression ratio is 1:11, in CI engine is 1:22. Generally it falls 6 to 12 bar in case of SI engine, while in case of CI engine pressure goes up to 35 to 40 bar. And also if I talk about the temperature, then in SI engine it goes 250 to 300 degrees Celsius, but in this case it goes up to 600 to 700 degree Celsius. Third criteria is suction. So mixture of petrol air is in calculator ratio is drawn into the cylinder. Only pure air is drawn into cylinder during suction stroke. Fuel, petrol and diesel, thermodynamic cycle, Otto cycle, diesel cycle understood. Weight of engine less because of lower compression ratio. As compression ratio I discussed in previous slide, it is nothing but the total volume upon clearance volume. So if I am talking about the volume, then it will definitely affect the weight of the engine. So more volume, if there will be more volume inside the engine, then the weight of the engine will increase. So in case of SI engine, compression ratio is less, so weight is also less. Efficiency lower because of lower compression ratio, because formula is given of SI engine 1 minus 1 upon r to the power gamma minus 1. R is nothing but the compression ratio. Speed high because of lighter engine, and here it will be lower because of heavy engine. So in this lecture of IC engine, I have completed the working and construction of CI engine and also the working and construction of two-stroke SI engine and CI engine, and also I have done the comparison between SI and CI engine. So this is for today's lecture. So thank you for watching this lecture. Thank you very much.